Hi children, welcome to my YouTube channel. This is the first video of the video series Surds. In this video, we are going to discuss about addition and subtraction of surds. What is a surd? Surd is a term or an expression left inside a square root or a cubic root, etc. For example, if you get square root of 5, the cubic root of 8, the cubic root of x to the power 6, etc. In this topic, we can identify two types of surds. The first type is entire surd. What do you mean by an entire surd? Entire surd is a surd where entire expression or elements remain inside the square root. For example, square root of 5. Here you can see entire expression or the term 5 is remain inside the square root. That is, the next term is square root of x to the power 6. Here also you can see entire expression x to the power 6 remain inside the square root. This kind of surds are called entire surds. The other type is just surds. When you consider a surd, part of the expression remain inside the square root and other part may remain outside the square root. For example, 3 root 5. Here 3 is remain outside the square root and 5 is remain inside the square root. The other example is 2y root x. 2y remain outside the square root and x remain inside the square root. These kind of surds are called the just surds. Now let's focus on how to add or subtract surds. When you add or subtract surds, we use the same principle what we have used for the addition or subtraction about algebraic terms. For example, if you want to add a plus 2a, what was the answer? Answer is 3a. In the same way, if you add root 5 and 2 root 5, you can say it is 3 root 5. How does we get it? We get 1 plus 2 is 3. There should be, then the answer should be 3 root 5. Remember, when you do this addition of surd terms, you cannot add the terms inside the root form. For example, if you want to get root 5 plus root 5, you cannot add 5 plus 5 keeping the square root and you cannot write it as root 10. Exactly this answer is root 5 plus root 5 is 2 times of root 5. Just like if you add a plus a, answer is 2a. If you add root 5 plus root 5, answer is 2 root 5, not root 10. You know that children, if you want to add 3a plus 2b, you cannot simplify them further. Only answer for this question would be 3a plus 2b. In the same way, if you add surd terms where the surd part is not similar, for example, if you want to add 3 root 5 plus 2 root 7, you cannot simplify this further. What is the reason? Because in the first part, the surd term is root 5, the other one is root 7. Therefore, you cannot add the terms where they are having different surd part of the question. Some students misunderstand that if you want to add root 5 plus root 2, they used to write it as root 5 plus 2 root 7. That is exactly wrong. As I mentioned in the previous slide even, you cannot add or subtract the terms inside the square root. So if you want to add root 5 plus root 2, you cannot simplify further. What is the reason? Because the terms inside the square roots are different, root 5 and root 2. Therefore, you have to keep the final answer in the same way as root 5 plus root 2. Let's come up with surd subtraction. Suppose that you want to subtract 2a out of 5a. What you need to do? You can just write it as 3a. 5a minus 2a is 3a. The same way, if you subtract 2 root 5 out of 5 root 5, that means 5 root 5 minus 2 root 5. Now you can see the surd terms are similar, root 5 and root 5. Therefore, simply you can write this answer as 5 minus 2, 3, 3 root 5. The same theory applies. You cannot subtract the terms inside the square root. If you happen to simplify root 5 minus root 2, you cannot write it as square root of 5 minus 2 as root 3. Root 5 minus root 2 cannot simplify further since these two terms are not similar. Therefore, your final answer ended up with root 5 minus root 2. Only the simplification where you can do with the questions like 5 root 5 minus 2 root 5 where the surd terms are similar in this expression. Now children, let's try to extend our knowledge using this example about addition of surds. In this example, they ask us to add 3 root 2 plus 5 root 3 plus root 2 plus 6 root 3. I have mentioned in the previous slides, you cannot add or subtract the terms with different surd expressions. For example, you cannot add 3 root 2 and 5 root 3. But you can see that you can add 3 root 2 to root 2 and root 5 root 3 to 6 root 3 because those terms are similar. Therefore, if you happen to add such surd terms, please make the similar surd terms close to each other. For example, I can bring 3 root 2 and plus root 2 close to each other and 5 root 3 and 6 root 3 close to each other. Remember that when you bring them, bring the surd term along with the sign in front of it. What is the sign in front of 3 root 2? It's plus 3 root 2. 5 root 3, that is 5 plus 5 root 3. Root 2, that is plus root 2. 6 root 3, that is plus 6 root 3. So when you bring this root 2, bring along with the symbol in front of that. Therefore, you can write 3 root 2 plus root 2 plus 5 root 3 and plus 6 root 3. Then if you simplify this, you can add 3 root 2 to root 2, that is 4 root 2. 5 root 3 to 6 root 3, you will obtain the answer 11 root 3. So that is your final answer. If you come up with this example, we have to simplify the surds 3 root 2 plus 5 root 3 minus root 2 plus 6 root 3. Now you can understand that the similar surd expressions are 3 root 2 and minus root 2. So bring 3 root 2 and minus root 2 close to each other. So when you bring this root 2, remember that as I mentioned in the previous slide, you have to bring along with the sign. So therefore you have to bring minus 2 root 2 close to 3 root 2. So you can write 3 root 2 minus root 2. Then plus 5 root 3 and plus 6 root 3. So we can write 5 plus 5 root 3 and plus 6 root 3. Then you can simplify 3 root 2 minus root 2 is how much? That is 2 root 2. 5 root 3 plus 6 root 3 is how much? That is turned up to 11 root 3. That is your final answer. Children, this is another example for you to verify the theory what we have learned. Here we need to simplify 6 root 5 minus 5 root 3 plus root 5 minus 8 root 3. So try to understand the similar terms. What are the similar terms over here? 6 root 5 and root 5 are similar terms. Then minus 5 root 3 and minus 8 root 3 are similar terms. Therefore, bring those terms close to each other. 6 root 5 plus root 5 minus 5 root 3 minus 8 root 3. Then you can simplify 6 root 5 plus root 5 is 7 root 5. Minus 5 root 3 and minus 8 root 3 is minus 13 root 3. That would be your final answer. Let's make this question a little bit challenging. Here we need to simplify 5 root 2 minus 3 root 3 plus root 5 and 8 root 2. Now try to understand what are the similar terms over here. The similar terms are only 5 root 2 and minus 8 root 2. root 3 terms are not similar with root 2 terms or root 5 terms. Therefore, simplify 5 root 2 minus 8 root 2. Keep minus 3 root 3 and plus root 5 apart from this calculation. Then you can simplify 5 root 2 and minus 8 root 2. You can simplify it and write it minus 3 root 2 and write minus 3 root 3 and plus root 5. Aha! How about this question? We had what root 12 to root 27. With our previous theories where we have learned, we cannot add the terms with different elements in surd expressions. Then can't we simplify further? You can see that root 12 and root 27 are a little bit of big numbers. Then can't you do something else to simplify this question further? Let's see. Our approach for this question is, if you get root 27, can't you simplify this further? Yes, we can. Then let's see how to get a much explained answer or much simplified version of the answer for root 27, which supports with adding two surd terms with big numbers inside in it. How to simplify root 27? First step is write this 27 as a product of prime numbers. You can say 27 is 3 into 3 into 3. Then you can write root 27 is square root of 3 into 3 into 3. Then couple the similar terms. You can see you can couple two similar terms 3 and 3. Couple them, take only 2. So you can get 3 and 3. Then you know that 3 and 3 is 9. No? We can take these couples out. That means you are taking square root of 9 out. What is the value for square root of 9? That is 3. Therefore, you can write root 27 is equals to 3 and the remaining term keep it as it is inside the square root. That is 3. Then you will get the answer as 3 root 3. Now let's get this example as well. We need to simplify square root of 108. How to write square root of 108 in simplified version? So you can write 108 as 2 into 2 into 3 into 3 into 3 as product of prime numbers. Therefore, you can write square root of 108 is equals to 2 into 2 into 3 into 3 into 3. Now couple the similar terms. What are the similar terms over here? 2 into 2 is one similar pair. 3 into 3 is another similar pair. Then 2 into 2 is 4. You can take it out. It will turn up into 2. 3 into 3 is 9. Square root of 9 is 3. So you can take 3 and 2 out from this square root term. What is the term remaining inside the square root? The term which is not paired is only 3. Then you can keep this 3 inside the square root and take square root of 4 out and square root of 9 out. Now you can write square root of 108 is equals to 2 into 3 into root 3, that is 6 root 3. Let's go ahead with another example. If you want to simplify square root of 450, we know that we can write 450 as 2 into 3 into 3 into 5 into 5 as a product of prime numbers. Therefore, you can write square root of 450 as 2 into 3 into 3 into 5 into 5. Then what are the pairs you can identify? The pairs are 5 into 5 is a one pair, 3 into 3 is another pair, but 2 remain isolated inside the square root. Therefore, you can take 3 into 3, 9. Square root of 9 is 3, so you can take 3 out as square root of 9. 5 into 5 is 25. So if you take square root of 25 out, that is turn up to 5. The reason is the square root of 25 is 5. Then you can take 3 into 5 out, keeping remaining term root 2 inside the square root. So your final answer turn up to 3 into 5, 15, 15 root 2. Now children, in previous slides, we have already learned how to convert an entire surd into a surd. Certain simplifications, we should know this opposite operation as well. That means we should know how to convert a surd into an entire surd. How to do this? What you need to do, this is pretty simple. Now square the term outside the square root and square it and bring it inside the square root and multiply by the term remaining inside the square root. For example, if you get 15 root 2, square 15 and multiply with 2 and write inside the square root. 15 squared is 225 into 2 is 450. This is pretty simple. Then if you get 6 root 3, square 6. 6 squared into root 3. That is root 72. So that is pretty simple. You can convert a surd into an entire surd very easily as shown in this slide. Now children, let's back to the section where I got stuck in our previous slides. How to simplify root 12 plus root 27? Simply simplify root 12. You can say root 12 is 2 into 2 into 3. 2 into 2 is a couple. If you take it out, that is 2 root 3. Root 27 is 3 into 3 into 3. So you can take a couple 3 into 3. You can write it as 3 root 3. Therefore, root 12 plus root 27, you can write it as 2 root 3 and 3 root 3. Now this is the pretty interesting section. Now these two terms which is not similar inside the square root convert into two surds where the terms inside the square root become similar. Then you can simply write it is as 5 root 3. If you go for another example, root 50 plus root 32. 50 is 5 into 5 into 2. So 5 into 5 is a couple. You can take it out and you can write root 50 as 5 root 2. Root 32 is 2 into 2 into 2 into 2 into 2 5 times. Therefore, you can take 2 into 2 one couple and another 2 into 2 another couple. Then you can take them out and you can write it as 4 root 2. Right. Therefore, you can write root 50 plus root 32 as 5 root 2 plus 4 root 2. Now you can simplify them further and you can write it as 9 root 2. In this example, we need to add root 50 plus root 27. If you write root 50 from the previous principles, you can write it as 5 root 2. Root 27 is 3 root 3. Therefore, if you add root 50 to root 27, answer is 5 root 2 and 3 root 3. Then you can understand that these two terms are not similar surd expression. Therefore, you cannot simplify further. Then you can write your final answer as 5 root 2 plus 3 root 3. So remember children, always the terms unlikely square roots with large terms won't be simplified further. Anyway, what you need to do is try to simplify them and see whether these two terms can be simplified further. But remember, always the further simplification won't be applicable. Okay children, let's try to understand this question as well. Here we have to add root 50 plus root 27 plus root 8. Root 50 simplification we already learned at the previous slides, that is 5 root 2. Root 27 also 3 root 3. And if you get root 8, 8 is 2 into 2 into 2. Whereas 2 into 2 is a couple, so you can take it out and you can write it as 2 root 2. Then root 50 plus root 27 plus root 8 become 5 root 2 plus 3 root 3 plus 2 root 2. Then 5 root 2 and 2 root 2 are the two terms where with similar surd expression. Therefore, you can simplify those two only. So, you can simplify 5 root 2 and 2 root 2 and you can write it as 7 root 2 and you can write 3 root 2 apart from this expression and you can write it as 7 root 2 plus 3 root 3. That would be your final answer. I will add a link for an additional exercise for you to try in the description box and it will pop up at the top as a suggestion videos. Hope you have enjoyed the video and understand the contents clearly. If you like the video, put a big thumbs up. Share the video with your friends, and to see more educational videos, please subscribe my channel and click on the bell icon. See you from next videos.